Hello, dear participants of the conference. We present a presentation on the topic using energy of compressed natural gas as an environmentally safe source of heat energy of the heating system of the industrial premises. The housing and utility system is extremely energy intensive and currently impedes the implementation of energy efficiency policies. In this regard, the development of science-based technology for environmentally friendly reasons, saving consumption of compressed natural gas as a source of thermal energy is becoming relevant. The article describes the technical solution for using the energy of compressed natural gas as a source of thermal energy, which consists in using a vortex heat exchanger in the heating system of a gas control station, which allows you to generate thermal energy due to technologically unused energy, which is the pressure drop between high and medium gas pipelines as well as medium and low pressure natural gas. This technical solution is aimed at reducing energy cost and ensuring environmental safety with using compressed natural gas as source of thermal energy. To determine the possibility of practical use of this technical solution in the production room for installing gas control equipment and analytical expression of the temperature of the wet gas mixture after the process of condensate, evaporative heat and mass transfer in vortex heat exchanger has been obtained, which allows us to predict the parameters of the coolant in the heating system of the production room. The resulting equation allows you to get the parameters of the heat carrier or the heating system of the production room closest to standardized. The experimental examination of the analytical dependencies was carried out in laboratory and industrial conditions on the installation, simulation, the heating element of the heating system of an industrial building, in particular a gas control station. We developed a mathematical model for the process of heat transfer in vortex heat exchanger from a swirling flow of natural gas to the air of the heated room became the basis for the creating in the concept of a vortex heat exchanger element. The operation of the gas control station is carried out under conditions when the pressure regulators operate at a sufficiently high differential pressure input and output values in gas pipelines with unclaimed discharge of the excess energy before supplying the consumer. The use of this energy of a moving gas stream is possible when using an excess pressure of the vortex tube as a partial absorber. On first figure shows the following symbols: a schematic diagram of a vortex heat exchanger element, the inner surface of the cold coolant supply pipe with a round groove connected to the both of contaminant removal device and longitudinally placed curved grooves, a profile of a helical groove in the form of a dovetail. In this flow of the hot coolant, this the flow of the cold coolant. In construction of the vortex heat exchange element, natural gas used in the vortex method of heat transfer is always saturated to a certain concentration with moisture, vapor, both atmospheric and technological. Therefore, as shown by the analysis of known vortex heat exchanges in a cold stream after thermodynamic separation of natural gas, consideration of moisture vapor with the release of heat of consideration is observed. The heat of consideration obtained in conjunction with the heat of the hot layer or the additionally stratified cold stream act on the cylindrical wall or the inner pipe. As a result, the thermal ratio of the counter-directed heat flows of the hot and cold heat carriers transferred by the thermal conductivity through the bimetallic fence in the form of a cylindrical the walls of the inner pipe 1. This virtually eliminates the possibility of efficient use the vortex method of heat transfer because the consideration process, especially drip, has a random nature of the release of the consideration heat over the heat exchange surface. To eliminate this phenomenon, to remove contaminant from the cold coolant in the form of condensed moisture vapor, the cold coolant is sent to the supply pipes 10 and 11, made in the form of tapering nozzles 18, where it increases its speed and moves along curved grooves 19 and twists. As a result, the particles of the contaminant fill the cavities of the curved grooves 19 and under the action of centrifugal forces move and learn towards the groove 21 located at the lane 20 of the nozzles 10 and 11, from where they accumulate into the pollution removal device 22 for discharge into environmental manually or automatically. The developed technical solution allows you to save gas as fuel in the heating system of a gas control point, eliminating the need to install gas control station in which water heating in the heating system is carried out by gas combustion. Then provide more comfortable working conditions for the pressure regulator due to a decrease in the differential controlled pressure or for gas entering the consumer. Since there is a significant decrease into the output pressure due to the operation of the vortex tube as a heat exchanger in the heating system of the production buildings, and increase environmental safety in the production of thermal energy, since there is no need to burn natural gas for heating the production premises. And so production of heat energy to maintain in microclimate in the production room is carried out by a regulated pressure drop of the natural gas. This is the end of the presentations. Thanks for your attention.